A very good morning I bid to Dr. Fateh and my fellow friends. My name is Muhammad Ali bin Azman and my matric number is 8E170035. So today I'm going to show to you how I make the code to get the value of this, which are AN, BN, and CN, and we'll get the graph like this, which are the graph voltage versus time with harmonic. So without further ado, let's get started. So I'll explain to you part by part of my coding to get the value of AO, AN, BN, and CN. So first, we have to integrate, like as you see in this formula right now. So there will be a AO formula, AN formula, BN formula, and CN formula. So to get this formula, there will be an integrate. So we cannot straightforward of the integration, which means F1 equal to T, and then integrate. It cannot because we need to assume the T. We need to declare the T, define the T. So to avoid that happen, we have to make a symbolic variable for T. So this is a symbolic variation of T for the purpose of the integration occur. And this is the period, which in ms millisecond, T20 millisecond. And that is a fundamental frequency, as you can see in the formula right now. Alright, so this is a fundamental frequency. And then this is a graph. This is how we define the graph. So for the F1 equal to 250, which is the amplitude or the voltage, times with the heavy side T minus 7.5 millisecond, and minus heavy side T minus 10. And for the F2, negative 250 times with the heavy side T minus 17.5 minus heavy side T minus 20. This I'm following the rule of this graph. Okay, and then we combine with two part, f equal to f1 plus f2, and this is the periodic function. Okay, for periodic function. So next, this is a AO. So to integrate, we have to put the symbolic version. So AO underscore SYM, which is a symbolic version, equal to 1 over T times integrate in terms of periodic function F time 0 until T. T is a 20, right? So, and then we have to change because if put only the symbol value, we cannot read the data that we get. Okay, so we have to change to the numeric value. So how to change? We put the coding AO equal to double AO underscore sim. This is AO underscore sims. And we get the numeric value and we can get the data. So for the next, we have to make a loop. The reason is because we want the number of n from 1 until 21, right? So we have to get the value of A, B, and C from 1 until 21. For that, we have to make a loop in Matlab. So the process is same like the AO. First, must put the A underscore sim n equal to 2 over T times integrate of the predict function time cos n. N is the repetition of number, which is 1 until 21, times with the fundamental frequency, times with the time, and then the value is T0 T, which means the integration must be 0 until T in terms of T. Okay, so same it goes with B. B underscore sim n equal to 2 over time, which is 20, times with the integration of predict function times sine times n times with the fundamental frequency times with the T, and the integration must be 0 until T, which is 20, and in terms of time. And C, for the C, as you can see, the C is just the A minus B times I. And that's the C. Okay, so this is the formula. This A underscore sim is like get this from this, and B underscore sim get from this times I. So we get the C. Okay, and then this is symbolic value. Same like before, we have to change to the numeric value to ensure that we can get the data and end the loop. So if I press the enter, I'm running the coding. So this is data, okay, in the workspace. This is called workspace, and there's two options how to read the data, and I will tell you these two options. First, if you want to see the A, for example, So just double click at the 1 times 21 double, and then it will get the data, and it seems like this, right? So it's same, negative 112.5395, same, and 3 same, 5 same, until 21. Okay, 21, still same. Okay, so the second option, how to read the data. So you can just type for example, if you want A, um, and then just click, just run the code. Then you will get the data. Wait, I will change my face. So, this is columns 1 to 11. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So just same, just like this. Same, right? If you compare for the A, same goes with the B. Just press B, just type B, and then run. It get the data also from 1 until 21. Same, right? Also C, as you can see, C. Okay, C I will explain a little bit detail. The reason because in the table that I can see right now, the table right now, C in term of magnitude and the angle. But in this here is a complex number. So, but it's same thing. If you want to read this C of the data, first it give this one times 10 to the power of 2. So you have to times with every column right here. Okay. So if you put your calculator, you want to change for the complex number, from complex number to magnitude and angle, is you get the same answer. So for the graph, first of all, we must ensure to get all this to put in the function. So what's the function? The function is something that when we want to use it, we just call it, and it will assign all the output and get the input also. So how to get the function? So just click the new and function, and as you can see in the editor, it's a function. There will be output argument. Output argument will be called, will be assigned. When we call it, how we call it, just put the title that we put it. And this is a case sensitive, which means if we wrong input the title, and when we want to call it, and for example, we use the big capital letter instead of small, then it will get the error. Okay, so it's very important. It's a case sensitive match. And this is the input argument. Input argument we get from the coding that we used before this coding. So we small this. So just copy and paste and put it. Just copy this one and put it here. Okay. So the same thing. So all of this coding will be put in the function. So for the title, we just name it Fourier series. Okay. So for the input argument, it will be the periodic function f, the time t, and also n. N is the number. So y is n, I will explain later. N is the number from 1 until 21. So for the output argument, so what we want to get in another coding that we made, first AO, A naught, A, B, and C. Okay, so it's very important. So this is the output argument, this is the title, and this is the input argument. Okay, so as for the last part, last step, how to plot the graph with the harmonic. So like previously, we already made the Fourier series function. So this is the function, right? So I already save it, and you should save it if you try with me. And then I keep it here. So for the next part is we want to plot the graph. So we must make a coding to ensure that we get the predict function, which is V voltage, and the time must be correctly graphed, and there should be harmonic. So they'll be coding for the harmonic. So I'll show you the coding. So okay, this is the coding, and I will explain to you bit by bit, very little, to ensure that we understand. Okay, so I just click the editor, delete the editor. So first Of course, the symbolic variable of t, the reason because in previously I said before this is important for the integration of the function, predicate function. Okay, so t 20 in millisecond, and fundamental frequency, like I said before, this is the formula. So this is a predicate function, how we can get the plot of the predicate function. And n, like I said before, n is a 21. So the reason why I make this n equal to 21, and if you see in the loop, n equal to 1 and n. So n is 21, so 1 until 21. So this is the important, like I want to highlight it. The reason because it will call all the output argument to ensure the data, all the data we got before this will put in here. Okay, so that's the reason. So we don't need to coding the same thing before this twice and put it here. Just put a function, this function like before, and all the data before this we get will be stored in here. Okay, so one thing, Fourier series is the title is very important. All right, the reason because if for example before this I make a big capital F and S, right? So it's a very case sensitive. This title is very has a case sensitive match. If we put the wrong, it will be error. Okay, so for example, I make it a small capital, small s, and I run it. Right, cannot find an exact case sensitive match for Fourier series. The reason because it is not as same as this one. This one. So if you put a big S in here, S capital letter, so this one also must be big capital letter. Okay, so I repeat again. I clear it all, and I paste it, and this is already big one. So before I running it, I will explain about the harmonic formula. So this is n cos n, which is 1 until 21. The fundamental frequency and t numeric. So what's the t numeric? T numeric is a time in a numerical value which is from 0 until 20. Okay, so this is the time to ensure that in the graph you will get the 0 to 20. So for the periodic numeric, f numeric, we use the AO and not. Okay, and next the harmonic one. So this is the formula. So for the f numeric equal to f numeric plus harmonic. So this is harmonic, and then we plot it in terms of x and y. So for the x will be time, and y will be a predict function, function numeric. So I'm also label it in time ms, and then the title voltage versus time, and the y labels is vo, which mean the predict function, which in the question is they use a voltage. Okay, so I run it. Okay, so this is the graph, and all the data that before this coding are already here, already stored here. So you can see it's same like in the question, right? The answer for the voltage versus time graph with harmonic. So that's all from me. Thank you.